Hey, top realized math industry, and we are gonna do and learn about an ionic bond. So, in chemistry, what is an ionic bond? Well, we know a bond has to be two things that kind of come together. And not only that, what's this? Hey, it looks like there's NaCl. Let's see what happens if we look at the periodic table. So on the periodic table of elements, looks like we have right here Na, and on the other side of it, we have Cl. So we have sodium and chlorine. So what that's gonna be right here is sodium chloride. That's sodium, that's chloride, chlorine, therefore it's sodium chloride. Also known as salt, the stuff that you put in your food for no apparent reason. So that is salt, but how can we explain what an ionic bond is? Well, if you notice that turns out there seems to be some kind of metal and also some kind of non-metal. If you look at the periodic table of elements, turns out that right here, and all this right here plus here is all the metals. This is an earth metal, or this is an alkali earth metal. These are transition metals, and here, behind it, and in front of this line, they're metalloids. So, an ionic bond has to do something when you have a metal and a non-metal come together. But hang on, how do the ionic bonds work? Well, what we have right here are two things, potassium and oxygen. What we have to do is find out what the formula is, but the problem is we have to look at their charges. Therefore, if we take a look at the periodic table of elements, each element is going to have a charge. And what we have over here is we have potassium right here, which is a charge +1. And oxygen right here, a charge -1. So what we have to do is change it around. So potassium has a charge of +1. Oxygen has a charge of -2. So what happens is, if we have these and we have an ionic bond, we have to crisscross the two. So now potassium has 2, and now oxygen has 1. Potassium has 2 atoms, oxygen has 1 atom. We could also write it like this. So that is going to be how ionic bonds work. But sometimes ionic bonds can get a little bit strange. When we searched up the charges for potassium and oxygen, sometimes there are elements that don't have a stable charge. Sometimes they have charges that may vary and also are very hard to figure out just with pen and pencil. Or pen and paper, I mean. So, here, the earth metals and the alkali earth metals have charges. The metalloids also have charges. However, the problem is, from this line here to that line right there, right over here, they're called transition metals. And these transition metals are kind of like the imposter of Among Us. Why? Because sometimes they don't have the same charges. Like for example, copper, the 29th element of the periodic table. Sometimes it could have a charge of 3, or sometimes it could have a charge of 2. If you want to denote this in chemistry, then what we would have to do is say copper, Cu, 1, 2, 3, Roman numerals, or copper, Cu, 1, 2 Roman numerals. Let's see what happens. So right here we have copper, 3 Roman numerals, oxygen. So copper, 3, oxygen. What that is going to say, that in this scenario, we're going to have Cu on the top of 3 and oxygen on the top of -2. Metals will always have a positive charge, meaning they would give the electrons over to the non-metals. So what we have to do is switch them around, crisscross applesauce. Therefore, we are going to say copper will now have 2 and oxygen will now have 3. And that is how we understand ionic bonds. Thank you for watching Tao Penalized Math Industry. Like and subscribe. Hey, Tao Penalized Math Industry, and we are going to take a look at covalent bonds. So, unlike ionic bonds in the last episode, covalent bonds are a little bit different. If ionic bonds are about metals and nonmetals, well, covalent bonds have to do with 2 things that come together that are both nonmetals. If you take a look on the periodic table of elements, on this side, from here to here, here to here, and possibly here, are all nonmetals. Like boron's a nonmetal, carbon's a nonmetal, nitrogen's a nonmetal. Mercury is a metal, but it's a different state. Argon's a nonmetal. Helium is definitely a nonmetal. So let's do an example. The most common examples that you would see would be CO2, or carbon dioxide. We're going to learn why we call them carbon dioxide. And the other thing is, another common is the ones you drink, H2O. Right there, hydrogen, what?